Hi everyone, today I will talk about the practical use cases for modulo. In computer science, the modulo operation returns the remainder when one integer is divided by another. It is usually abbreviated as either MOD or the sign here you can see it's the percentage sign, depending on the language you're using. So let's start. The first use case I will usually use for the modulo is to find even or odd numbers. And how we can do that is, for example, we can say 6 modulo 2, it will always equal 0 because it's divisible by 2. But if we say 7 modulo 2, it will always equal 1. So we can see for even numbers, when it's modulo 2, it will always equal 0. And for odd numbers, it will always equal 1. If we want to test if a number is divisible by 5 in Python, we can do something like if when modulo 5 equals 0, another use case that I can think of is doing something every nth time. It's very similar to this. So let's say we want to do something for I in range 1 of n, and then if I is divisible by 5, then we do something here. Another use case I would say is it's useful when we want to convert something, like when we want to work with time. So for example, we can convert seconds to display it in hours, minutes, and seconds. So how we can do that is, like, for example, we can say 582 seconds, and by converting 582 seconds to hours, we can do 582 in 3,600 seconds, and then this will round to 0, right, because it's not. And then for the minutes, we can do 582, 60, and the modulo is 60 for the 60 seconds. And then this will equal 9. And then for the seconds, we can do 582 modulo 60 seconds, and then this will equal 42. So what this means is 582 seconds rounds down to 9 minutes and 42 seconds. Another one is we can force a number to be evenly divisible by another number. So for example, if we want multiples of 10s, we can do x equals x minus x modulus 10. So x modulus 10 will always give you like the last digit in a number, and then if you make x minus the last digit of itself, x modulus 10, it will always be a multiple of 10. It might be a little bit confusing, so I'll show you an example. Let's say our number is 49. 49 minus 49 modulus 10 will equal 49 minus 9, which will always equal 40, which is a multiple of 10. Let's do another example. Let's say our number is 50 minus 50 modulus 10. The next use case I can think of, typically used in programming, is we can find when we're rotating an array. Let's say the question is for us to rotate an array a number of times, but if we rotate it more than the length of the array, then we can actually simplify it by rotating a minimal number of times. I can show you. So let's say find out how many times to rotate array if the number of times we need to rotate is k and k is greater than the length of nums. So basically, if k is greater than the length of nums, then we'll rotate it k equals k modulus length of num times. So as an example, I can show you if nums, let's say nums equals 1, 2, 3, 4, 5, and then k equals 7. We want to rotate this 7 times. But do we actually really need to rotate it 7 times? We don't need to, right? At the 5th time, it will already be at the original position again. So basically, what we need to do is 7 modulus 5, which is the length of the array. Which is equals to 2. So this is basically the same thing as rotating it 2 times. Yeah, so these are all my use cases that I thought about for the modulus sign. And one thing we need to look out for is also we need to make sure this is like a remainder, division remainder thing. So we need to make sure we cannot divide like modulus 0. So let's say 22 modulus 0. This will return 0 division error. So we cannot do this. This is wrong. I hope you enjoyed my video and got some more insight on how to use the modulus sign. Thank you for watching.